Okay, today I'll be explaining 7 different topics. I'll be explaining the properties of waves, know the relationship between frequency, wavelength, and amplitude, compare light waves and sound wave, explain how light can behave, explain the characteristics of the electromagnetic spectrum and how it is organized, explaining resonance and how it can have an impact on other objects, describing how different waves on the electromagnetic spectrum have an impact on our daily life. And then lastly, I'll be explaining how the ear receives and interprets sound. First, properties of the waves includes frequency, wavelength, amplitude. Frequency is the number of waves that is measured in hertz. Wavelength is the measure of crest from one crest to another. Amplitude is the height of the wave, and then the relationship is that if the wave have a higher frequency, it means it has a shorter wavelength, and then if the wavelength is longer, meaning the frequency will be lower. And then also amplitude affects how fast waves are being produced, or the intensity of the waves. I'll be comparing light waves with sound waves. Light waves are electromagnetic waves, while sound waves are mechanical waves. Light waves can travel through a vacuum, while sound waves are required to travel through a medium known as a solid, liquid, or gas. And then light waves have a higher frequency, while sound waves have a lower frequency. And light waves are also visible. Uh, they also and their similarities, light waves and sound waves, their similarities are that they all behave through something called reflection, refraction, diffraction, and interference. Uh, now, now how light wave works. Now, what reflection means? Reflection means that when light hits like an object bounces off, for example, when light hits a mirror, it would bounce off and reflect. Refraction means uh, when light travels through a medium and it like changes. For example, when a straw gets put into water, the straw looks like it's bent, but really it's straight. Diffraction means when light bends around an object. For example, if you put a bottle cap in front of a flashlight, the light would bend around the bottle cap. And then interference is when light wave starts to overlap and it becomes bright. We're talking about the characteristic of electromagnetic spectrum and how it's organized. So electromagnetic waves, electromagnetic waves are organized in something called electromagnetic spectrum, and then in the spectrum it includes 7 different waves. You have the radio wave, microwave, infrared, visible light, UV, ultraviolet, X-ray, and gamma waves. In the electromagnetic spectrum, they are organized in this way is because they go organized from the longest wavelength to the shortest wavelength. Example, radio waves. They have the longest wavelength and they are used in communication. Also, as you go down the list, each electromagnetic spectrum starts to hold more energy, which gets more dangerous. Radio waves are the least dangerous. They have the longest wavelength and they're used in communication. Microwaves we use in cooking and also in radars. Infrared, we use them in like remote control, visible light. We could actually see it. For example, visible light, we use them in cameras, and then we use visible light so we can see through our eyes. Now, ultraviolet minus UV uh is sunlight basically. And then X-ray, it's used for medical. It's used for like medical imaging. Gamma waves, they're the shortest wavelength with the highest energy, and then they are used to fight off cancer. Resonance means that when an object starts to vibrate and has the same vibration frequency as a natural object, then it will break. For example, resonance. For example, the Como Bridge. Tacoma Bridge, resonance occurred, saying that the vibration of that object matched the natural vibration, which then caused the bridge to sway around and to collapse. Another one would be a wine glass. When resonance occurs, the vibration of the wine glass would match the natural vibration, which then the wine glass would shatter. Now I'll be describing the different waves on the electromagnetic spectrum and how it impacts our daily lives. So, I said there was a radio wave, microwave, infrared, visible light, UV and ultraviolet, X-ray, and gamma wave. Radio waves, we use them for communication, for example, radios, TVs, and cell phones. Microwaves, we use them in our everyday household. We use them to heat up food, and microwaves are also used in radars. Infrared, they're using like thermal imaging, and night vision, and also remote control, like a TV remote. Visible light, I said that we use them in cameras and in vision, so we can see. Ultraviolet, known as the sunlight, we can use them for medical, I guess, because ultraviolet waves, the sunlight, they produce vitamin D, which is essential for our body. It could also be dangerous because you get sunburns and cancer. And the X-ray, we use X-rays in the hospital. We use them for medical imaging. For example, if you broke your arm, the doctor will tell you to go take an X-ray so then they can see which bone you broke, and then they can fix it. The gamma waves, we use them in medical as well because we use them for cancer treatment. Okay, now I'll be talking about how we explain how the ear receives and interprets sound. Okay, so I'll stay in the next video.